This video is the start of descriptive statistics. First of all, we're going to start with different types of data. So we can have univariate data, which only has one variable. Qualitative data is data that is not given numerically, such as red cars, blue cars, yellow cars. Quantitative data is numerical and can be classified as discrete or continuous. So discrete data is either data that can be counted or data that can only take specific values, such as how many cars pass through a traffic light. We can't have half a car, we can only have one car, two cars, three cars, etc. Then continuous data can be measured. Something like height or weight is continuous because if we were able to measure it down to a smallest minuscule unit, if our device was able to do that, then we could. Here's an example. The ages of boys in a football club are, in the table as follows. State whether this data is discrete or continuous. In this situation, the data would be classed as continuous, as age is a continuous variable. You are not just 10 years old, you are 10 years old, and then how many days or how many months, how many days, how many seconds, how many milliseconds, it could be measured right down to a small, minute detail if possible. Therefore, it is continuous. And then part B, construct a group frequency table for this data. Let X represent age. A grouped frequency table, we're going to have two columns. For our grouped frequency table, our first column will be age and our second column will be frequency. Now with this, it doesn't tell us how to make our groups, which means it is completely up to you. I am going to do my groups as my first one. My age is going to be from 10, as that is my smallest age value, all the way up to 12. Now I'm writing it this way as I'm saying here that I'm going to be including 10, but everything up to 12 and not including 12. And that's because we don't want 12 to be covered under two intervals. So the next interval, I would have 12 less than or equal to x less than 14. Now we can see the clear distinction is if the age of one boy was 12, he would go into that second group, not the first group. If I had made this one here that I'm circling an equal to as well, and it was somebody 12, we wouldn't know which group to put it in. So this clearly identifies which group somebody that's on that boundary will go into. Next, we'll have from 14 up until 16, and then 16 up until 18. And then we're just going to go through and count how many we have in each of those groups. And when you do that, we would have 16 in the first group, 10 in the second, 9 in the third, and 5 in the fourth. There are multiple different sampling techniques that we may need to be able to define or identify in an exam situation. The first one is convenience sampling, which is where we select the most easily accessible members of the population. Example of that would be you need to survey 10 students, you go to your class and you select the first 10 that you see. That's convenience sampling. Simple random sampling, members of the population selected are randomly generated. Systematic sampling, list the members and select according to a random starting point and a fixed interval. So we would write down all the students in our class and we would say we wanted to sample 5. Then I could say I'm going to start at the second student and I'm going to go every 3 after that. So I start with student number 2, then I do the next, skip 3 students, then select the next one. Select 3 students, select that one. And then, that's how that one works. Stratified sampling, selecting a random sample where numbers in categories are proportional to their numbers in the population. In a school, we had 40% males and 60% females. Then I was maybe going to sample 10 students. I would need 40% of those students to be male and 60% of the students to be female out of the 10 that I'm going to sample. Quota sampling population is split into groups based on relevant factors, and then we would use convenience sampling, which is select the most easily accessible members from each group, and that is what we use in our sample. Here's an example. In a school, there are 137 students in Year 8, 152 in Year 9, 174 in Year 10, 168 in Year 11, and 121 in Year 12. A sample of 50 students is needed. How many should be randomly selected from each year? So in this one, we are going to be using stratified sampling, which is where we select proportionally. Now, the first thing we need to know is how many students we have in total. So our total number of students would be adding all those year level numbers up together, and we would get 752 if we did that. Now we want to work out proportionally how many are going to be picking from each year level. So our total sample size is 50 students. To do that, let's start with Year 8. we have 137 students in year 8, which we would find out the proportion of year 8 out of the whole school, which will be 137 divided by 752. Now we want 50 students in total, so therefore then we multiply that by 50, and we would find that would be 9 students out of year 8, proportionally. And we do the same for all the other year levels. Year 9 had 152 students, so it would be 152 divided by 752. What proportion are year 9s out of the whole school, and then multiply by 50, our sample size, and we will get 10. Now I'm just going to complete the rest for you to get our total sample. And there you go, that tells us how many we need to randomly select from each year level, so it was proportionate. We want 9 from year 8, 10 from year 9, 12 from year 10, 11 from year 11, and 8 students from year 12. And that's the end of this video.